Welcome back to Math Enhancement. In this video, we're going to discuss what will happen, what are the formulas we can use to get the sum of the roots and the product of the roots of a quadratic equation without actually solving for the roots. Okay, so if the roots of the quadratic equation, whose general form is ax squared plus bx plus c equivalent to 0, are identified or defined by your quadratic formula, then we have exactly two roots, one of which is negative b plus the square root of b squared minus 4ac all over 2a, and the other one is negative b minus the square root of b squared minus 4ac all over 2a. So if we will be asked to get the sum of the roots of the quadratic equation, our symbol for that is capital letter S, that means we're taking the sum of x sub 1 and x sub 2, your root number 1 and your root number 2, and actually it will result to negative b over a, where b is actually the numerical coefficient of your linear term and a is the numerical coefficient of your quadratic term. To prove that to you, okay, let me write down here that if you have x sub 1 be equivalent to the negative of b plus the square root of b squared minus 4ac all over 2a, and that x sub 2 is equivalent to the negative of b minus the square root of b squared minus 4ac all over 2a. And let's say we're being asked to solve for the sum. That means we take x sub 1 plus x sub 2, sum of the roots. By substitution of the above formula, you get negative b plus the square root of b squared minus 4ac all over 2a plus x sub 2, which is negative b minus the square root of b squared minus 4ac all over 2a. Since these two are similar fractions, that means they take the same denominator, we can simply add their numerators. So we have negative b plus the square root of b squared minus 4ac minus b, so we simply add, minus the square root of b squared minus 4ac. In this manner, negative b, okay, plus negative b will result to negative 2b. So we have here negative 2b, while positive square root of b squared minus 4ac will be cancelled because the other one is a negative b squared, negative square root of b squared minus 4ac. Therefore, in the numerator, you have there negative 2b all over 2a. That cancels 2. And that results to a sum which is equivalent to negative b over a as in our formula. This is how you get the sum of the roots. Okay? For the product of the roots naman, so if we will be asked to take the product of the roots, that's simply solving for x sub 1 multiplied to x sub 2. So again, substituting the values of x sub 1, that's negative b, plus the square root of b squared minus 4ac all over 2a, we are going to multiply this to negative b minus the square root of b squared minus 4ac all over 2a. So as you can see, the numerator makes transforms, or the numerator looks like we have a product of binomials, the same two terms, the product of the sum and the difference of the same two terms, right? So that will result to a difference of squares as a product. So therefore, you'll get negative b quantity squared minus the second term, which is the square root of b squared minus 4ac quantity squared all over, the denominator will be 2a times 2a, so you get 2a quantity squared. Simplifying our numerator, you will get this as positive b now. So negative b quantity squared is positive b. Minus squaring the radical, will remove the radical sign. So minus the quantity, do not forget that you're preceded by a negative sign or a subtraction. So you have to apply a parenthesis to make sure that you'll be able to distribute that negative sign all over 2a quantity squared. That would be 4a squared. Okay, so let's simplify this. So this one's b squared, sorry. So that would be b squared minus b squared plus 4ac, right? Distributing the negative sign all over 4a squared. And we'll have b squared to be cancelled. You'll get 4ac all over 4a squared. We'll be able to cancel 4 and one of the variable a in the denominator and 1 in the numerator. So that will result to an answer which is c over a for the product of the roots. So instead of solving for the roots themselves, we can just simply memorize that if you're solving for the sum of the roots, that's negative b over a, and then for the product of the roots, that's c over a. If one root is negative of the other, you just have to remember that that happens if the numerical coefficient of the linear term is equivalent to 0, or that means you do not have a linear term in your equation. Therefore, one of the roots will be negative of the other. Okay, so let's apply all this knowledge in solving problems. So specifically, you have problem number 1. So we are being asked to determine the value of the constant k, so that the expression or the equation x minus k quantity squared equivalent to 3k plus 1 will get equal roots. So let's write that down. Okay, so let me write here example number 1. We are being asked to find the value of the constant k so that the expression x minus k squared equivalent to 3k plus 1 will have equal roots. So this means we should be able to apply everything that we learned starting from the first video of quadratic equations up to the last one. Okay, up to this one. So what characteristic or maybe what property of the quadratic equation will make its roots equal? And that is by the use of your discriminant, right? If your discriminant, which is b squared minus 4ac, is equivalent to 0, it will create roots which are real and equal. So what we're going to do is transform the given relationship or equation to a general form, which means you have to expand this. So this will become x squared minus 2kx plus k squared is equivalent to 3k plus 1. And then we have to write this in its general form. So you have there x squared minus 2kx plus k squared minus 3k minus 1 is equivalent to 0. Considering this a quadratic equation, x squared will form your ax squared, diba? And then your negative 2kx will form your bx. And then everything that does not contain your constant or your unknown variable x will be considered your constant. Okay, therefore, you have a equivalent to 1. Okay, b will be equivalent to negative 2k, although k is unknown, x is also unknown, but k will represent a part of the constant, the numerical coefficient. So b will be negative 2k, and then your c will be equivalent to k squared minus 3k minus 1. Okay, having that, we're going to use all these values to solve or to substitute in the relationship or in the equation b squared minus 4ac should be equivalent to 0 to get equal roots. Okay, so by substitution, that will result to b squared. So that's negative 2k quantity squared. We just substitute this here. Okay, minus 4 times a, which is 1, times c, which is k squared minus 3k minus 1 equal to 0. Okay, applying or expanding, simplifying the equation, that will result to, we have here positive 4k squared, okay, minus distributing the negative 4 to all these terms, okay, that will result minus 4k squared, okay, and then negative 4 times negative 3k, that's positive 12k, negative 4 times negative 1, that's positive 4. Equate that to 0 and simplify. So in simplification, you notice that 4k squared is positive and negative, so we cancel that. Then you'll be left with 12k plus 4. Applying everything we learned in linear equations, we solve for the unknown, which in this case is k. So we have here 12k equal to negative 4. We move all terms that does not contain the unknown to the right side of the equation. And then solving for k, we divide both sides by 12. Okay? In that sense, k will be equivalent to the negative of 1 over 3. And this is the answer we are looking for. What is the value of k in the relationship x minus k squared equal to 3k plus 1 so that it creates equal roots? Now, if you want to check if your answer is correct, okay, check. What you're going to do is, again, get your equation, that's x minus k quantity squared equal to 3k plus 1. We have to prove if the roots are equal. So we're going to let k be equivalent to the value we are able to solve, that's negative 1/3. So we're going to substitute that in the original equation. You will have x minus negative 1/3, so x plus 1/3, that makes it positive, quantity squared, equal to 3 times negative 1/3 plus 1, okay? In that sense, you will have your x plus 1/3 quantity squared equivalent to negative 1 because 3 will be cancelled, plus 1, that makes the right side of the equation equivalent to 0. So you have your x plus 1/3 quantity squared equal to 0, okay? And then, if we take the square root of both sides of the equation, it will result to x plus 1/3 equal to positive negative 0. So that's still 0. Okay. Therefore, you get x equal to negative 1/3. And since this is a quadratic equation, you have two factors which are both x plus 1/3. Therefore, each of them will produce negative 1/3 as a root. Therefore, you have equal roots. They are both negative 1/3. So that's how you solve it. Okay. What you do is, of course, you get your equation, identify what's the particular characteristic or what's the particular condition given in the problem. Sabi dyan, the equation that will result to the expansion of this one will have equal roots. So therefore, you have to identify which of the principles we learned actually specified about equal roots. And that is through the characteristic of roots topic, diba? In the characteristic of roots topic, we were able to get that you will have equal roots if the discriminant will be equivalent to 0. And that's what we did. We transformed this in the general form so that we will be able to identify which one is B, which one is A, which one is C. After being able to identify which in the expanded equation, expanded form or general form of equation stands for A, B, and C, we use these values, although they have unknowns, which is K, we use them to substitute in your relationship in characteristics of roots, specifically in your discriminant. After being able to substitute, we expand, we solve for the unknown, and then we're able to solve for K. If you want to test if your answers are correct, again, use the original given in the equation, substitute your answer, which is negative 1/3, and then check that if you solve for the roots, will they be equal? And yes, they turned out to be equivalent to each other. Okay, so that's how you solve it. Okay, that's how you solve these kinds of problems. Okay, let's proceed to example number 2. So for example number 2, let's get our blue pen and write example number 2. So in this problem, you have to determine again the constant k, determine the value of the constant k so that the products of the roots of the equation, okay, you have an equation given which is 2x squared plus k minus 3x plus 3k minus 5 equal to 0. Yung product of the roots daw of this equation equals the sum of the roots. So if we're going to write that down, the product of the roots in this equation, that's p, right? It specifies p. The product of the roots of this equation is equal to the sum of the roots, equals the sum of the roots. So that equivalent to s. Okay? So, therefore, if you know the formula, diba? Every particular equation can be solved, every particular quadratic equation, we can solve for its product of the roots knowing the formula. That the product of the roots is simply equivalent to c over a. And the sum of the roots is simply equivalent to negative b over a. In that sense, if you're going to simplify that, since both of the denominator is equivalent to a, you get to cancel that. Okay? Therefore, the constant term of the equation should be equivalent to the negative b, the negative of the numerical coefficient of the quadratic equation. So going back to your quadratic equation, we have to be able to identify which is which. So obviously, your quadratic term, x squared, will be accompanied by a. Your x term will be accompanied by b. Okay, and the remaining terms that do not have the unknown x, so these ones, will be considered the constants. Therefore, we use these values. What are the values again? A is equivalent to 2, b is equivalent to k minus 3, and c is equivalent to 3k minus 5. We are going to use these values to substitute in this relationship we were able to derive because this is mentioned in the problem. The product of the root should be equivalent to the sum. So substituting, in place of c, we replace that with 3k minus 5. So we get here 3k minus 5 equal to the negative of b. What is b? Of course, with the negative sign, you have to introduce a parenthesis, of course. B is equivalent to k minus 3. And then we proceed with simplifying the equation. So you have there 3k minus 5 equal to, we distribute, that's negative k plus 3. And then, we take all the unknowns on the left side and all the constants on the right. So you get there 3k plus k, if you transpose this, equal to positive 3. Transpose this also, that's plus 5. Okay, so you get 4k on the left and 8 on the right. So dividing both sides by 4, you get to cancel 4. And you'll be able to solve for k that's equivalent to 2. And this is our answer for this problem. Okay, so if you want to check again, get the original equation. So that's 2x squared, okay, plus k minus 3 times x plus 3k minus 5 equal to 0. We substitute in place of k, si 2. So that will result to 2x squared plus 2 minus 3x plus 3 times 2 minus 5 equal to 0. We just substituted in place of k, si 2. So we get there 2x squared minus x. So that's 2 minus 3 is negative 1. Okay, 6 minus 5, that's positive 1, equivalent to 0. So, para hindi na tayo mahirapan, let's get our calculator to solve for the roots of this equation. Okay, you have there 2, negative 1, and positive 1. The roots will be x sub 1 is equivalent to 1/4 of negative I times square root of 7 plus 1. Okay, and then the second root, x sub 2, is 1/4 times positive I times square root of 7 plus 1. So we have to prove that the sum and the sum of the roots will be equivalent to the product of the roots. So let's take x1, x2 first. So that's p x1, x sub 2. That's equivalent to 1/4 times negative I square root of 7 plus 1 multiplied to 1/4 times I square root of 7 plus 1. So, multiplying the real numbers, you get there 1 over 16. And then multiplying the binomial to the binomial also, you have here the sum and difference of the same two terms. So, that means it will create difference of squares. Therefore, you'll get here negative the square of the second term. So, I square root of 7 squared plus, okay, the second term squared. Okay, simplifying that, that will result to 1 over 16 multiplied to the negative of, okay, I squared is equivalent to negative 1. So that's negative square root of 7. But square root of 7, if squared, that's positive, that's simply 7. So negative 7. Okay, paano naging I squared equals negative 1? That's because I is equivalent to the square root of negative 1. So square root of negative 1, quantity squared, that will give you negative 1. That's why I squared is negative 1. Square root of 7 squared is 7. So you get negative 7 plus 1. So we get 7, positive 7 plus 1, that's 8. Okay, that's 8 divided by 16. We get 1/2 for the product of the roots. Okay, if we are solving for the sum of the roots, that's x sub 1 plus x sub 2. So that will give you 1/4 multiplied to the negative I square root of 7 plus 1. Okay, plus 1/4 times the positive I square root of 7 plus 1. So to add this, we have to distribute the constants that we have, and that will produce the negative 1/4 I square root of 7 plus 1/4. For the second term, that would be positive 1/4 I square root of 7 plus 1/4. And as you can see, these two terms are similar but opposite in sign. So that means by addition, they will be cancelled. Therefore, you're left with 1/4 plus 1/4. That's 2/4. And 2/4 is actually 1/2. Therefore, we conclude that the product is indeed equivalent to the sum. So, it was not specified in the problem given if the roots will be imaginary or real. It just said that the sum and the product of the roots will be equivalent to each other. So, what we did in the problem is, write the equation of the condition, substitute appropriate formulas, simplify. Using these formulas, we get their values from our equation given. We substitute, we solve for the unknown. We were able to solve that k is equivalent to 2, which is the unknown in the problem. Okay, let's proceed to the last example. Example number 3 says, we have to determine the value of k again. Determine the value of the constant k subject to the indicated condition. So in letter A, we're being asked to solve for k in the equation 2x squared minus 3kx plus 5k equal to 0, which has one root twice the other. That means one of the root, that's let's say x sub 1, is equivalent to twice the other. So that's 2 times x sub 2, right? One root, which is x sub 1, is twice the other root, okay? For this kinds of question, I suggest that you use either product of the roots or sum of the roots as your working equation, okay? So if you have sum of the roots, diba, your sum of the roots is simply equivalent to x sub 1 plus x sub 2, and in equation, that's equivalent to negative b over a. What you're going to do is substitute this condition that one of the root is twice the other in this particular equation, so that in that case, you will have to substitute in place of x sub 1, diba? X sub 1 will be replaced by 2x2. So you'll get 2x2 plus x sub 2 will be equivalent to negative b over a. That means you have 3x sub 2, your sum of the roots, will be equivalent to the negative of b over a. And then, you go over your equation and then identify what are b, a, and c. So from the given equation, which is already arranged in the general form, you have a equivalent to 2, b is equivalent to negative 3k, and c is equivalent to 5k. Substituting these values in this equation, that will result to 3x2 be equivalent to the negative of b, which is negative 3k, all over a, which is positive 2. Okay, in that sense, you'll be able to simplify this as 3x sub 2 equivalent to positive 3k all over 2. You can multiply both sides of the equation by 2 to remove the fraction. So you will get 2 times 3 times x sub 2 equals 3k. In that sense, 3 is also common on both sides of the equation. So if you divide both sides by 3, that will simply be cancelled. Okay? So therefore, twice one of the root is simply equivalent to k. If you try to use the other principle, which is product of the roots, diba, if we're solving for the product of the roots, that's x sub 1 times x sub 2, and that's equivalent to c over a. Okay? Substituting, we know that x sub 1 will be replaced by this relationship. So x sub 1 will be substituted by 2x2, multiply that to x2 also. That's equivalent to c. Your c here is 5k divided by a, which is 2. And then again, we simplify. So if you're going to simplify, this will result to 2x sub 2 squared, okay, is equivalent to 5k all over 2. In that case, we can multiply both sides by 2. Okay, we multiply both sides by 2. That will cancel the right side. And you'll be able to produce 4x sub 2 squared is equivalent to 5k. What you can do here is, you can use these two equations, diba? You use these two equations to solve for the unknown. You can use this relationship that k is equivalent to 2x2 and substitute it to this equation, diba? And that will result to 4x sub 2 squared. 4x sub 2 squared is equivalent to 5 times k. K is equivalent to 2x2. So if I substitute that, that will result to 4x sub 2 squared equivalent to 10x sub 2. Okay? If I solve for x sub 2 is common on both sides. So if I divide by x sub 2 once, I'll be able to cancel on the right side. 1 will be cancelled. Okay? And that will result to 4x sub 2 on the left equivalent to 10. So solving for x sub 2, I divide both sides by 4. Okay, that will cancel 4 on the left side. You have x sub 2 equivalent to 10 over 4, which is 5 halves. This value that you're able to solve, you substitute it to any of the equations you were able to create, like any of these two, to solve for k. So definitely, I'll just use the first equation. So if k is equivalent to 2x2, okay, if k is equivalent to 2x sub 2 and x sub 2 is equivalent to 5 halves, that will create 2 times x sub 2, which is 5 halves. If I substitute it, that will create a value of k, which is actually equivalent to 5. And that will be our answer for this example problem. So what's the next thing to do? Of course, the next thing to do is to check if the answer is correct. So if k is 5, let's get our original equation. Our original equation is 2x squared, okay, 2x squared minus 3kx plus 5k equal to 0. If k is equivalent to 5, we substitute that here. So you will get here 2x squared minus 3 times 5 times x plus 5 times k, which is 5 again, equal to 0. We'll be able to simplify this as 2x squared minus 15x plus 25 equivalent to 0. The condition in the problem is one of the root will be twice the other root. So what we're going to do is get our calculator and check the roots that we have. So you have there 2 equal to negative 15 equal to positive 25. So you'll be able to get roots wherein one of the root is 5 halves and the other root is 5. So, diba tama naman? If you take twice of one root, so kung dodoblehin mo to, si 5 halves, you'll get 5. So, one root is twice the other. Okay, which means our answer where k equal to 5 is correct. Okay, and that's how you use your sum and product of the roots to solve these kinds of problems. If I may recall what I did, again, I wrote the equation given, that's 2x squared minus 3k plus 5k equal to 0. The next thing I did is write the condition in the problem, that's x sub 1 equal to 2x sub 2. After that, I used the two principles, sum of the roots and product of the roots, to come up with two equations. So, I substituted this, knowing that the sum is simply x sub 1 plus x sub 2, I substituted this here. I was able to create this, and I know the formula for the sum, that's negative b over a. I took the value of a, b, c from the original equation given with k as part of the constant but is unknown. So, we have 2, negative 3k, and 5k, and I substituted that also to this equation. In that case, I was able to create this equation that, if simplified, will produce k equal to 2x sub 2. After that, I used the other principle, which is product of the roots. That's x sub 1 times x sub 2, which is equivalent to c over a. I did the same thing, simplified the left side, substituted the values for the right side, simplified the equation, so I get this one. After being able to get two equations with two unknowns, you have x and k, x sub 2 and k appearing on both equations, I used one of this relationship to substitute to the other equation. Being able to substitute means being able to simplify the two equations into one so that you get to bear just one unknown. And in that case, you'll be able to solve one value, okay? After being able to solve for x sub 2, you use this value to substitute to any of the two equations that you used. Both equations, if you substitute x sub 2, which is 5 halves, you'll be able to get that k will be equivalent to 5. And that gives you our answer. So I hope you'd be able to use the same thing that I did to solve for letter B and letter C. Okay, that will be for you to solve so that you can test if you understood what you learned. I'll be giving you your answers. I'll be giving the answers for B and C. So for letter B, for example, letter B, okay, the answer for k is 0. The resulting equation would be 4x squared minus 9, equivalent to 0. Again, as in the problem, one root is negative of the other, so you're going to use the third principle under sum of the roots, sum and product of the roots, diba? Where b is 0 if one root is negative of the other, okay? And then for letter C, the value of k is equivalent to the positive negative 5 over 9, okay, which will result to two kinds of equation. So the equations you'll be able to get are 4x squared plus 20x plus 9 equal to 0, and the other is 4x squared minus 20x plus 9 equivalent to 0. So there are two possible equations you can create on letter C because you have two values for k. And that's it. Try your skills if you're able to learn anything from quadratic equations.